I can't hear you. Can we have a louder cheer? Energy? Good morning everyone once again. The special cases, secretaries of various departments, all the eminent professors representing various institutes, the support team, media, and my dear children in the back. I'm very excited and happy to be here today. If you can hear me at the back, can you raise your hand? Okay, great. So, what I will do quickly is I will talk about my mission in a very short way form, and thereafter we will move on to some question answers that you would want to ask me. Okay? So before I start, let's see a quick movie. I don't know if all of you have seen this before, but this short movie tries to capture my journey, my mission, my training in the last year. And then once we have done that, we will move on to the topic for which we are here today. Prosperity through science. So let us see this movie and we'll quickly move on to the presentation after that.
I just want Bulgarian people to know that we did this. We were able to achieve this. And it completely doesn't matter for me who is in this room. I am proud, but I just want them to be proud as well. 7, 6, 5, 4, 3, 2, 1, and lift off.
It's an amazing feeling to be in orbit for the first time. When I looked out through the window for the first time, the view was just stunning. Wow, what a ride it was. But when the ride started, it was something like you get pushed back into the sea. It was an amazing ride. And then suddenly, nothing. It was an amazing feeling. We also want to thank you for basically thanks for everyone around the world, every person on the team who made this beautiful day happen.
Grace crew, welcome aboard the International Space Station. Peggy, welcome back. It's a great honor and privilege to have such a legendary astronaut on board with us. And Thibaut, Shubhanshu, congratulations on your first space flight.
Thank you to all participants. Stay tuned, we are now resuming operational audio communications.
I travel to space with the dreams of a billion hearts with me. I want them to live this journey with me because I feel that it is equally theirs as it is mine. Because I feel that this is truly the journey of an entire nation.
And look where we can go when we work together on common platform, common science. Then sky is no longer a limit. We can explore space, we can explore science, we can explore technology and build new solutions for the future. The Explore crew came here with a purpose and a really busy agenda. This was a great mission and we enjoyed it the most. So now we will return home and we will spread the word in our countries that these things are within our reach. These things are possible even for smaller countries like ours.
It's always great to work with a bunch of professionals, which you are, but it's even more special to work with folks that have become our friends even more deeply. Thank you.
Thank you to the Acting 4 crew. think it's really important to have these examples of people to show the new young generation that actually there are no boundaries. Your dreams, your careers, and your lives have no limits. This is what you dream of, then you can pursue.
You come up with problems which you otherwise did not know, and then you have to find solutions or solve those problems, which now give you very unique perspectives or solutions to other domains or other areas which you did not even know before. When India's space program was being set up by the Vikram Sarabhai, Homi Baba and the likes, they had something very clear in their mind. And the philosophy with which they were setting this up was, we must be second to none in application of advanced technologies for the benefit of society. So the thought was always in the background that we have to use for the science, for upliftment of everyone. So when you travel to space, again, it gives you a very unique perspective. It forces you to solve problems because it is an environment where life should not be existing. There is no air, there is no water, there is no protection from radiation. But you not only sustain life, but you also thrive there and you conduct science. So this is what technology innovation does when you try to solve extremely complex problems. And historically, I think as a nation, we have always been very heavily focused on science. In 1975 and 76, science experiment was one of the very early experiments which was to spread education using satellites. This is 1975-76 we are talking about, and it remains the largest socially conducted educational experiment till date. We've lost the presentation, that's the thing. And then with missions like, INSAT, NAVIC, and the human space mission, the mission Gaganyaan that we are pursuing, I think we are furthering this idea. Last year when I was training, I was thinking about this issue, and when I was reading, I came across a fact that highlights how we treat science. I think India is the only country which has in its constitution as one of the fundamental duties to create scientific temper in the country. And that is the importance that we as a nation accord science. But let's move on to the mission now and see why it is so complex, it is so challenging. When I was going for launch, I was really confident, really prepared. I felt that I know everything because the training had been very exhaustive, very intense. But when the rocket engines ignite, when the Falcon 9 engines they ignite, everything you know, you just forget immediately. It goes right outside the window. And that is how different the actual scenario is. So when you develop something, when you create something, you don't have to just create a solution. You also have to think where it is going to be used, under what circumstances, under what situation. And that is what allows you to create these problems in the right way for the right user. So, what are solutions or challenges we have to navigate? So for all the people sitting in the front segment, and obviously the kids are behind, I don't think that they would be really interested in these problems that I'm talking about, but the problem, if you just look at the launch, you have to solve how to save the crew if something goes wrong during this highly dynamic phase. You're going from 0 kilometers to 28,500 kilometers per hour in just about 8 minutes. And that is the kind of dynamism that it possesses. How do you save the crew when something goes wrong? How do you plan for recovery? You can save the crew, but you are going to land somewhere south of Australia, thousands of miles away from land. How do you get them back? The training should reflect that. The support team training should reflect that. The communication should enable all these things. So it never really remains a simple problem. It becomes an extremely complex one. But once you finish all this, you reach space. And space is two things. It is very disorienting, but it is a lot of fun. When you get to space, you don't have an idea of up or down, left or right. You just forget about it because there is no gravity. So even if you are upside down, you don't realize that. You think that wherever your head is the side that it is up. And the concept of space also changes. You don't really, in this big hall that we are sitting, it is a three-dimensional hall. But we don't use the 3D space, we use 2D. All of you are sitting on sofas, chairs, and you will walk out on the floor. Nobody is walking on ceiling, nobody is walking on walls. And this is what is interesting about space. You can really use the 3D space. I remember my first day, I was supposed to be going across a module and there was an astronaut working right in the center. And I saw her and I stopped and I was waiting because I could not pass. And then this other astronaut comes to me and she asked me, why are you not going? And I said, because she is in the way. And this astronaut starts laughing and she takes me by my hand, takes me to the ceiling and tells me, walk here. And then I started walking on the ceiling or walking on the wall. And that is how it changes, your concept of how you utilize space when you get there. And the other thing is understanding of microgravity. Gravity is there, but it is not being perceived because everything is in a free fall. So if I was to leave this bottle of water, it will stay here, it will not fall. But your mind doesn't know that. You have gone from Earth. So I would ask in the initial days, if I have to leave something, I would ask someone, can you please hold it for me? And then these are also first-time fires, they would also hold it. And everybody is floating, everybody is falling, but they would also hold this and stand next to me. Only after a few days you realize that it is not required. Something that you can see in this video. See how you can use the cameras and the everything. So I'm sure some of you would have felt when I was leaving the lens that this will fall. This will go down. I have had the same feeling in the initial few days. The problem, you get used to this. In around 7-8 days, you become really used to, you can leave things and everything is okay. But then it's time for you to come back. And when you come back to work, this doesn't work. You cannot leave things here on Earth. Which I learned the hard way. I was working on a laptop the first night. I closed it, put it on the side and I left it. Thinking that it will float. Unfortunately, it did not. It fell down. But the mind is a really powerful tool. It makes you believe things which are not existing, which are not there. And that is the lesson that I learned. When you go there and when you come back, there are things that happen if the environment is new, and your mind really takes time to get used to it. The other interesting concept is the concept of weightlessness. The International Space Station is a huge structure. It is about 100 meters long, actually the size of a football field. And it was not possible for us to make that if it was not for this concept of weightlessness. Because of weightlessness, it is possible for astronauts to lift heavy things and construct this entire thing. And again, somehow we have lost the presentation, but I will continue to explain the concept. There is only mass. There is no weight. There is no concept of weight. So I was traveling with this lady in an aeroplane, and when I told her this concept of there is no weight, she was extremely happy. She said, that is the place I need to go. I need to weigh myself in space when I get there. Because the momentum is to be controlled, but the huge structures, the huge payload drag, all of them are possible. You can lift them with one hand. You can move them around very slowly, very gradually. Okay, since we don't have the videos and the presentations, I will quickly move on to the last part, which is the recovery, when you come back. Oh, we got it back. So see this, how interesting this is, the concept of weight. This is a huge bag which is used to transport very heavy equipment or payload bags inside the station. You can lift it, but you have to be careful with the movement. And I would let you guess what is inside this bag that is as heavy as it looks like.
International Space Station.
So that is about 250 kgs of weight that you are moving around in space very easily. You know, it is just mass, you have to be careful. But this is the unique trait which allows us to make this station in the first place. A lot of physiological changes happen. Your body has never seen this. Or you lose a lot of weight, your muscles start getting degenerated, you have brain fog, headaches, nausea, you don't feel hungry because everything inside your stomach is also floating. So your stomach feels full all the time. You also grow taller in space by 5 to 10 centimeters. But the problem is that I was also very excited with this fact that I can gain a few inches. But when you come back to Earth, you come back in height, so it is not a lasting change. But all of this forces you to find solutions of how to live a life in space. Similarly, there are a lot of psychological challenges that you have to address. Confined space, stressful environment. There is some alarm going on all the time, every time. And especially when we are talking about going to Mars for a long duration mission, these are going to be very challenging problems that we need to solve. The other huge part which a lot of you who were sitting here in the first section have contributed to was science in space. For the first time, we were able to conduct microgravity research and bring back the data and analyze it. So more than the experiment itself, I think the learning of how to enable an experiment in microgravity was a huge way. So I'll quickly go over what we did. So a few of them. One, biogenesis, which is studying of how muscles regenerate and how to prevent it. This is also got uses on ground. And you can see my smile in the image on the left. This was the day when we were doing microscopy and we got very positive, encouraging results from what we were testing on board. So I was very happy. All the PIs who were sitting on ground were very happy and we had a great laugh at it. The other experiments were growing cyanobacteria as an alternate source of nutrition for the crew, solving problems of food security. Then we also took seeds to see the effect of microgravity. They have been brought back and they will be evolved for 5 generations to see what are the changes that they go through when they experience microgravity. Then we also do macro-LD again with the same intention of finding a possible source of nutrition for the crew. And also on ground, these are problems which are going to solve your food security problem. We also took movement making in space and see how interesting it is. The image of the light that you see, it is a wall of the station, it's a side wall. So there is no workbench required. You can carry out your experiment on the ceiling or on the wall, wherever you are. You just fix it to the Velcro and that is your work desk, ready wherever you want it to be. We also studied tardigrades. They are known to be extremophiles and we wanted to know what makes them survive in these extreme environments. Can we learn from them? Can we devise a mechanism to protect through an extremely long duration mission? And lastly, we also studied how to reduce the cognitive load on astronauts, especially when interacting with screens in the environment of microgravity. Along with this, I also participated in international experiments, which was brain-machine interface, audio-visual evaluation, and astro-mental health. And this was the first time that brain-machine interface was carried out on board the International Space Station. So what happens when you conduct science? One, you get a very unique perspective because the environment is very different. And the second, the biggest lesson I feel is when you enable an experiment in space, you learn this entire process, which is not simple. You have to prepare the samples, you have to load it into the rocket some 24 to 48 hours before. You have to have right temperature conditions. Then you have to create the experiments in a way that it can be done in space because the environment is really different. And I think learning of this part was the biggest lesson for us, for the country. agencies which are apart, the research institutions, and people from ISRO. I think we have learned the ecosystem, and now we know how to do it. So when you finish everything, and then there is time for you to come back again. This time when you come back to Earth, your body has forgotten how it is to be on Earth. You don't even remember how to walk. I thought when I was landing that I know. I was feeling good, so I thought I'd be able to walk. But when I took my first step, I was falling down. And then the second step again, I was falling down. What has happened is that your mind has forgotten how much effort it takes for you to stand, walk, sit. It doesn't remember that. So it changes everything. This is me 2 hours after this splashdown, and look how I'm struggling to walk. The problem is not that you don't know, you don't have the strength. It is just that your mind has forgotten. You cannot walk, whatever you do. And it takes some time for you to get back, get adjusted to this environment where you have been all along, grown, evolved in the environment of gravity for just 20 days, and you forget everything. Your body forgets everything. You have to relearn it again. So lastly, what is the plan? We already have mission Gaganyaan, Bharati Space Station, and landing on the moon by 2040, laid down in space policy 2023. But this time when we go to moon, it is not going to be like 1960s. We will go to space. We will have a sustained presence. And this will involve enabling of long duration space missions, development of key technologies. It is projected right now that by 2033, India's space economy only will grow to $44 billion. But that is based on the statistics that we have today. I have a feeling that it will be a higher figure than this. Because when you develop something for space, for moon, going for missions like this, you need to develop technologies, you need to develop science, and you need to create a scientific and industrial infrastructure all around us. And everywhere I go, I talk about this, whether we talk about space or we talk about science or we talk about anything. Finally, at the end of the day, it is a collective national effort for the benefit of our country. And everybody is a part of it, and everybody has to contribute to this. So why do we go there? We go there for upliftment of everyone. Like we said, we started out with this cause, that the technology should be used for benefit of society. And we carried that even today. While I was on station, I interacted with children who were sitting in the back. Unfortunately, I can't see them eye to eye. But in my interaction, there was a kid from Northeast India who asked me a question. So, भारत के Northeast क्षेत्र के एक छोटे से गांव का बच्चा एस्ट्रोनॉट कैसे बन सकता है? And to me, that was such a big moment and such a big win. That when you ask this question to me today, I don't answer back with hesitation. I have an answer. I know what the solution is. I can tell it. This is how you can become an astronaut in today's India. It is not a dream anymore, it is a reality. And this is not just with astronauts, this is with everything that we are doing and progressing as a nation. And the last statement that we said, the point that is there on the slide, is Viksit Bharat 2047. And that is a dream that we have as a nation, that is an ambition, that is a goal that we have. So my call to every one of you who is sitting here, and even in the background, the kids who are sitting there, if you are listening, if you are hearing me, my call to you is that it is your responsibility to take India from here to be a developed nation by 2047, not anybody else's. It is my responsibility, it is your responsibility, each and every one of us. We have to own that, we have to believe that, and we have to continue to this. With this, I end my presentation by showing to you that how bright India looks from space. And let us verify that it already looks very bright. And I am not just saying literally because you see the lights, in all the sense, symbolically also it looks very bright. So let us have a look how India looks from space. You would see India in the night. You will be passing over Bangalore, Hyderabad, and you will see New Delhi in the distance. You will also see flashes that will happen, which are essentially lightning happening. And then in the end, we will see a sunrise from space. Let us have a look at it. Can we bring the light, please? Virgin Media, and you see the Bangalore city that is coming in the front, Hyderabad, Pune, and in the distance you see New Delhi. And look at the flashes that you have, these are all lightning that are happening. And this is the sunrise. So when you look at this site 16 times a day in space in 24 hours, I cannot but say the lines that were said by our first Indian astronaut, ऊपर से भारत कैसा दिखता है, and even today I can say सारे जहाँ से अच्छा, जय हिंद, जय भारत.